Yeah, hi everyone. My name is Darla, and I'm going to show you a little bit about Neon today, and then show you how you can deploy your contract on it. So first, we'll just go over the architecture of Neon. So Neon is basically like a gateway for Ethereum developers to Solana, and you can just go ahead and deploy your Solidity-based EVM-compatible code on Neon without having to modify it. So the main benefits are that you don't have to code in Anchor or anything like this. You can use your familiar languages, and all of the Ethereum tools are compatible with Neon. And then you also get all of the Solana benefits as well. So like parallel execution, low fees, high speed, and you can interact with Solana dApps from Neon. Here we have the core components, which is an EVM itself, which is a program on Solana, the proxy server. And then we have like Faucet, Neon Pass, which acts like a bridge. And here are some ecosystem partners. So we support a lot of projects that work with Ethereum that makes the transition to Solana through Neon really easy. And next, let's just look into how it works. So if you are a dApp developer and you have your dApp and like the front end, you basically just interact with the Neon proxy as if it was a Ethereum RPC. So for you, there is no difference. And then all of the magic happens inside the Neon proxy that can interpret EVM bytecode and make it Solana compatible. And then this proxy forwards Solana transactions to the Neon EVM program, which is a smart contract on Solana. And it processes the transactions in parallel where possible, and also stores the state on Solana and on Neon. So here we have like a classical Solana program. So this is an example of why it's possible to execute things on Solana in parallel, because you have the immutable execution part, and then you have the program derived accounts. So if your data doesn't have to be touched or modified in a concurrent way, you can just execute transactions in parallel, and Neon EVM as a Solana program takes advantage of that and makes your Ethereum-like transactions parallel through that. And this is an overview of of Neon EVM program itself. So we have the Neon EVM program, and then it has Neon account and the Neon contract. And then when your Neon transaction comes in, it creates program derived account addresses where possible, and executes the transactions that you send to it. And here's an example of how data is packaged on Neon to Solana transaction. So we have a Neon EVM address and then a list of Neon accounts that need to be communicated with during the transaction that you send, account list that you pass, and then all of your data of your Ethereum transaction, value and transaction data itself, nonce, gas price, gas limit, all of that familiar stuff that you basically have on Ethereum. Okay, and this is the example, the scheme for parallel execution. So here we have as a starting point the Neon proxy that already had turned your EVM bytecode into a Solana transaction, and it goes to Solana RPC endpoint, which communicates to a Solana node. So here we have the Neon EVM program, and again, like I said, it has Ethereum-like accounts, a list of Ethereum-like accounts, and also Ethereum-like contracts. And here we have an example of here we show that we also store Ethereum-like contract storage, not only on Solana, but inside the Neon EVM program itself. And here are the main ecosystem partners. So it's possible to bridge, since Neon is fully Ethereum, almost fully Ethereum compatible, it's really easy to bridge ERC20 tokens to it from like Ethereum, Polygon, any other chain like Base or Arbitrum. And then you also have a Neon Pass, which to the outside user looks like a bridge, but actually it is not quite a bridge, because Neon is itself a program on Solana. So it's essentially, you can think of it as a wrapper that wraps tokens, like Solana tokens, to be compatible to Neon through an ERC20 interface and vice versa. So this makes the token transfer from Neon to Solana very easy and fast. So you don't have to like use the bridge if you're going that way. So yeah, just to reiterate again, the main advantage is that since you, like if you have your Solidity code and Solidity project, you can just go ahead, and in most cases, you can just go ahead and deploy your code through like Hardhat or Foundry or Truffle if you're using that on Neon, and it will be, and it will have access to all of the Solana ecosystem. So next, I will actually show you how you can do it, and if you want, you can also follow along if you have, I don't know if you have downloaded Foundry. So to start, I'll just make like a new project. Sorry, 1 second. I think it's like Forge init Neon test. Yeah, and okay. So let's go into Neon test, and we can open it with Xcode in another window. So as you can see, it's just a simple counter contract that you get with the default Foundry project. And
Hey,
we
sorry,
are
Daria.
going.
I think
Yeah,
you're
yeah.
still showing the slides. We're still not
Oh, sorry.
seeing them.
Okay, good
Yeah.
point. Sorry. Okay. I'm gonna reshare. Actually, I'm gonna quickly make a .env file with my private key and then reshare the screen. Okay. So it's okay. Okay, so basically what I did, I just went ahead and made a new Foundry project through Forge init, and this is what I got. I haven't changed anything. We have like a deployment script and the contract itself, and then I have also created a .env file with my private key and also the RPC URL for Neon DevNet, which you can find on Chainlist. So you can do the same thing. I'm just not going to show it because it's like a private key. So next, what you would do is you can do essentially all of the same thing that you do with your Ethereum project. So you're going to source .env file so that you can access your environment variables like with your private key. And then it will be a standard deployment command for Foundry, which is like forge create, then the RPC URL, your private key. And then we are also going to need the path to your contract. So it's gonna be, I think it's like counter.sol, and then you also need to specify the class. So it's going to be counter, and I don't think it has any constructor arguments. And also because not all of the RPC methods are compatible on Neon, there are like some are absent. It's not many, but like, for example, all of the RPC methods, not all, but some of the RPC methods relating to gas fees are like always returning 0 because gas works obviously a little different. And the native token is not Ethereum, it's like Neon. So we can't use that. So we have to go with like -- legacy. And then if you press enter, it will just go ahead and compile and then hopefully deploy. And this is where like the most interesting part will start because I'm going to show you how it is deployed not only on Neon, but also on Solana. So here we have it has deployed to Neon DevNet. And we have the deployer, it's my address, this is the contract address, and this is the transaction hash. So I'm going to copy that and reshare my screen again. And we're just going to go to Neon Scan and check out the deployment transaction. And we need to switch to DevNet. So this is the transaction that we have just initiated. So it's like finalized. It's a contract creation, and we have like our contract created over here. So this is all of the interface. It looks completely like almost like Etherscan, very familiar, very simple. But the cool part is, I need to move this thing. The cool part is if you go over here, you can see a Solana transaction. So if you click, you'll be able to go ahead. Okay, Sol Scan is like always terribly slow, so we're gonna open Solana Explorer instead. So we're gonna paste this transaction hash that we got from the Neon Scan. Okay, we need to switch to DevNet as well here. Okay, and here we go. Here's our transaction. So it is the same transaction where we have deployed our contract, but as you can see, there's like a little bit more accounts involved because like I explained, to run in parallel and to be compatible with Solana, the Neon EVM program like creates some of the program derived addresses and handles all of that. So this is actually the Neon EVM program on DevNet, and this is the instruction data. So here we just have like a simple counter contract, but actually if we wanted to, we can find data from this Neon EVM transaction over here, but I'm going to show it to you on a better example, which I have done previously for experiments on like cross-chain communication. So it's going to be a little bit more comprehensive. So basically what I have done is I have sent a message from Ethereum to Neon EVM through Hyperlane, and the message was this. It was like hello and a smiley face, and it resulted in this transaction on Neon DevNet. This is like another block explorer, but I like it better, but it doesn't show the Solana transactions. So here we can see like we decoded. Here's the message, so it's on Neon DevNet. And then if we, let's go and copy this and go to Neon Scan. So it's going to be the same transaction. And then we have like this Solana transaction over here. So let's open it on Solana Explorer. And go down to the data. And here we have this data like data slice that is actually our message. So let's find it here. Yeah, I think it's this. It's this, and if we go to like a hex decoder, we can actually see that it is in fact our message. So I guess the point that I'm trying to make here is that if you can see it on Neon, you can also see it on Solana, so that basically makes your app capable of communicating data to both networks. So if you are making, for example, like a identity verification app or something like that, if you just deploy your Solidity code on Neon, you basically have like Solana covered as well, which I think is really cool. Yeah, so and another point that I wanted to mention is because of this feature that I showed, Solana is composable with Neon. So that means that you can interact with Solana programs through from like through Neon. And because Solana has this feature called like cross program invocation, you're basically able to make a call to Neon EVM, and it will make a call to the Solana program that you're trying to communicate with. And actually, I am preparing a tutorial on that, so check it out if you're interested. And I think that covers it. So if you guys have any questions, I can go into it more. Let's chat.
Guys, if you have questions, I allowed unmute capability, so you can unmute yourselves if you have questions.
How much does TPS does Neon EVM have? Actually, I'm not sure from the top of my head, but we can go to Neon Scan and see. It's like pretty big because I think we don't have like enough transactions that we need. Like it's basically like close to Solana. I don't think we like get enough traffic on the network for it to like to be overrun. Because it's basically like a program running on Solana, so it's like as fast as you can go, I guess, on Solana. Yeah, and another point, like if you are interested in doing something with Neon during the hackathon, like I used Foundry in this example, but you also can use like Hardhat and stuff like that. So feel free also to do that. And I'm gonna just link our docs so that you can have like a quick start on that over here. Yeah, I think that's pretty much like covers everything that I wanted to go over.
All right, cool. Okay, let me just open this document real quick. So in case they have to reach you or they have more questions, they have like a Discord channel or Telegram group. Maybe you can drop it on the link. I mean, on the chat. Where we can reach you.
Yeah, one
Okay.
second. I'm gonna try to open Discord because like sometimes it just doesn't want to open.
Yeah, sure.
But yeah, we have on Discord we have like a developer channel where you can ask all of your questions. We have like also developer series on Neon, and we are regularly like making pretty fun, hopefully fun, like I hope they're fun because I'm making them, tutorials. Oh my god, I'm so terrible at Discord. Yeah, so actually like the next one, like I said, so this is our Discord. Yeah, and the next one is actually gonna be, I think, on how you can send tokens from like other networks to Neon without like using the bridge. So keep like look out for that as well. Yeah, this is our Discord. Just join and like ask all the questions you have. And thanks, thank you guys for coming to this tutorial.
Thank you. Thank you so much, Dari, for your time as well. You know what? I was also checking the what do you call this? The documentation you sent. And yeah, it's very helpful. Even the Discord link is here. I mean, so feel free to check this documentation, guys, so you can also go through it and join their Discord. All right, so I think we're set unless you have other questions, guys. One last question, by the way, Daria, if you don't mind. So
Yeah,
since we're on a Solana global hackathon, what do you think are the best maybe ideas to build or to integrate Neon in their project?
That's like a good question. I think like one of the ideas that I am currently like super hung on into is like something I'm not like I haven't formulated yet, but something with like cross-chain like verification or identity stuff where you basically like by using Neon you get like Solana for free if you like parse the transaction data correctly. I would say something like this would be pretty cool because like interoperability is like a super hot
Right.
topic at the moment. Yeah, also I guess um, something it's like a little harder because it involves like composability between Neon and Solana, but something where you can interact with like AMMs or exchanges or whatever, whichever actually programs you're interested on Solana through your Solidity-based dApp. I think that is also pretty cool.
Yeah, that's a good one. We have another question here. How to use for coding in our project? Oh, what do you mean,
So
France?
yeah, I mean
Maybe.
I think I can sort of answer it like you just use like you basically the benefit of going with Neon for the hackathon is if you're more familiar with Solidity rather than Rust and Anchor framework, but you still want to like participate in the hackathon with your Solidity code, you should just deploy your dApp to Neon. So this is, I guess, the answer is it just really simplifies your life as a like developer.
Agree. Because I think yeah, I mean if you're more fluent, I guess, in Solidity, definitely. Um, you can
Yeah, it's much
use
easier
Neon,
to be
right?
like it's much easier to be fluent in Solidity than Anchor.
Okay. Yeah, I think we're good. Daria, again, thank you so much for your time. And definitely we'll go to Discord channel and meet you if you have questions, definitely. And you mentioned you will not be coming to Token 2049, right? But is there any activity by Neon for the Token 2049? Maybe you can share that or
Yeah, you can actually I can share our Twitter. We have everything related to that there, and we will
oh
be co-hosting an event at Token 2049. So you can
okay.
go there. It's like pretty cool. Like it's not just us; it's like other ecosystem partners. So it's gonna be pretty cool. Okay, Twitter is like misbehaving. One sec.
Yeah, sure.
Um,
Let's see. I'm also checking uh Neon. Okay,
Neon
got it.
EV. Yeah.
Neon underscore EVM. Okay, we'll definitely check this. Because we will be going to the token 2049, so we can drop by. Maybe we can drop by and check more
cool.
stuff about Neon EVM and of course the cool folks behind the Neon. All right,
Yeah,
so I
we
think
have
we're
like
all
some.
set. Yeah. Oh, sorry. Go ahead.
No, never mind. Yeah, I was just wanted to say that we have like some pretty technical folks coming there as well, and thank you very much for inviting me. It's like super fun to do those workshops. So thank you again for having me here.
Thank you as well for your time. So yeah, folks, again, thank you for coming as well. Those in the chat, or who participated tonight. Again, this session is recorded. We'll just post it in our social media channels or send it to our communications. Thank you again. I think this is the end of the night. Enjoy the rest of your day, Daria, and folks online. Bye.
Bye.
Bye.